So today begins the start of Module 5, which covers Chapter 5 of the textbook, which is all about methods. We'll look at an introduction to methods, how to pass arguments to a method. We'll delve deeper into local variables, returning a value from a method, and problem solving with methods. So why do we have methods? Well, they are a very good way to take a large problem and divide it into smaller parts. This is often called divide and conquer. Methods help to simplify a program, and also we can reuse parts of the code. So if we have a smaller problem that we've created a solution to, we can put that in a method and just call it whenever we need it. So this saves a lot of work because we don't have to rewrite that code or copy and paste it. Again, we can just write the method once and call it when we need it, whenever we need to solve that same problem again. Now, we have used methods in this class. We've used methods that are created for us by Java. An example of a method that we've used is the printline method. The printline method is an example of a void method because it performs a task, but it does not return a value. It does require a parameter, also called an argument, of type string in order to function properly. A value returning method performs a task and also returns a value back to that section of code that called it. So in this example, the parse int method takes in a value of type string and returns a value of type int. We do have to be prepared to accept that value that's being returned, either through an assignment or some other means. Otherwise, the program will not compile. So we can't just ignore the value that's being returned by a method if it returns a method. We have to do something with it. We've defined a void method several times in this class. The main method, right? Remember our best friend, the main method, public static void main, etc. That is an example of a method that is a void method. It does not return any value. In order to define a method, we have to have a header and a body. The header tells us about the method. It tells us whether it's going to take arguments, whether it's going to return arguments. It tells us the name of the method. And then the body contains the instructions about what the method will actually do. So here's an example of a method declaration. Here's the header. Public static void should look familiar to us. Again, void means this will not return a value. We'll talk more about what public and static mean in a moment. Display message is the name of the method. Note the camel case convention here. Okay, in other words, if the method contains 2 or more words, the first word is all lowercase, and then any word after that begins with a capital letter. There should not be spaces or special characters. Actually, there cannot be spaces. If you put a space there, you'll get a compilation error. The special character that would be allowed is the underscore, but I do not recommend it. Simply put the words together and start each subsequent word with the capital letter. Then the body here, this should also look familiar to you. This particular body simply has one command in it, and it's delineated by the open curly brace and the closing curly brace. Anything in between there is going to be the body of the method. Here we have the parts to the method header, again, just identified a bit more clearly. The method identifiers, we have public static in this example. We'll talk about what that means in a moment. Return type. This return type could be a data type, or it could simply be void. Void means it will not return anything. Then we have the name of the method and the parentheses, and inside the parentheses is where we designate what arguments or parameters the method is expecting. If those parentheses are empty, then the method does not take any arguments. Now, those modifiers that we've been using a lot, public and static, here's what they actually mean. The public modifier means that the method is publicly available to code outside of the class. So it's available anywhere within the program. Whereas, and also the static method, not whereas, the static method means that belongs to a class, but not to a specific object. So we can create a method that's only available to one object, one instance of a class, but we're not going to do that today. We'll simply use the keyword static, which means that it belongs to the class, and anytime we create an instance of that class, that method will be available to that object. We've talked about these already. Now, to call a method, all we need to do in the case of a method that doesn't take any arguments and doesn't return a value is we just simply give the name of the method as a command. And that's the whole line. So the name of the method is display message. The parentheses are empty because this doesn't take a value. There's no assignment because this doesn't return a value. And that's it. That calls the method. Now let's look at some examples of methods just so we can see how these work in actual code. So starting with simple method.java. So here we have, this should all look familiar, public class. The name of the class is simple method. That's the name of the file. We have our best friend, public static void main, which we now know is actually a method. It's the main method. The main method will be called whenever this program is executed, whereas other methods may or may not be called. Okay, they're called by code. The main method will automatically be called. So here we have a print line. So this is displaying a message that we're in the main method. Then we call this display message method, which will call this method down here. So let's take a look at how this is declared. Notice that this method is completely outside of the main method. Okay, the main method starts here and ends here, and then this other method is defined and completely outside of the main method, but it's still inside of simple method. In other words, it's still a part of this class, but it's not a part of the main method. So the main method calls this other method. There's nothing passed in and nothing returned. Simply performs this task, hello from the display message method. And that's all this does. So let's go ahead and run this and we'll see this working. So here we have the three print lines. It first calls this print line to show us that it's in main. Then it performs this print line inside of the method. After the method is complete, it returns back to the code immediately after the point at which it was called. So it returns to here and then executes this line. So it goes from main to the method, then back to main. Questions on that? We got another example, loop call.java. So in this example, we have the call for the method inside of a for loop. So keep in mind that all these concepts that we're learning can, for the most part, be combined. So in this example, we have a for loop. How many times will this for loop repeat? 5 times. So it starts at 0 and actually counts to 4. So it will call this method, which is inside of the loop, 5 times. So it will display this message, hello from the message, etc., 5 times, and then go back to main. So let's go ahead and run that. Okay, so it starts in main, displays this message. It calls the display message method 5 times, so that message gets displayed 5 times. And then when the loop is done, we move on to the next line, and we're back in main. Questions on that? Okay. Look at creditcard.java. So this has 2 user-defined methods in it. Let's take a look at this. We have a variable called salary of type double, a variable called credit rating, which is an int, and a string called input. We ask the user what their annual salary is through a dialog box, then store that in this variable called salary. We ask the user to supply their credit rating on a scale of 1 to 10 and store that in this variable called credit rating. Now we have a compound if statement. If the salary is greater than or equal to 20,000 and the credit rating is greater than or equal to 7, then they qualify for the card, and it calls this method qualify. Otherwise, it calls this other method no qualify. Let's take a look at those methods. Here is the method for qualify. It simply displays a message, congratulations, you qualify. And no qualify displays the opposite message, I'm sorry, you do not qualify. And then we have to call this system.exit to close the show input dialog, actually the JOption pane class. So let's go ahead and run that. All right, so give me some numbers. We want to test this thoroughly, test all the different combinations of values. Give me a salary. What's that? 17,000? Oops, sorry, I typed 17. Sorry about that. Okay, scale of 1 to 10, credit rating, 10. So $17 a year with excellent credit, you do not qualify for the credit card. Okay, give me a different set of data here. Little louder. 17,000 again. And credit. Well, let's pick something that'll make it below 7. So yeah, 3. So again, it says you not qualify. Okay, 50,000 and 7. Congratulations, you qualify for the card. And let's do one more. So we'll have a high salary and poor credit. You not qualify for the card. Okay. So again, the main point of this example was to show that we can call methods from inside of an if-then-else clause, and that we can have multiple methods within the same program. We can have as many methods as we like. We can keep going. This particular actually has 3 methods, right? We have the main method, which is automatically called. Then we have these other 2 methods that are only called under certain circumstances. So a method may or may not be called, with the exception of the main method, which was always called. Now let's look at deep and deeper. This example shows that we can actually call one method from another method. So in this example, we start out in main, and we call this method called deep. And we look at the definition of deep. Deep displays a message, and it calls another method called deeper. Here's the method deeper. Simply displays a message. From there, it would go back to deep and pick up where it left off, display this message. And then from there, it goes back to main, picks up where it left off, and displays this message. So the end result is that it says, I'm in main, then in deep, then in deeper, then back to deep, and back to main. So we can call methods from methods, and we can go as many levels deep as we like. Now, eventually, your computer will run out of memory, but it would be pretty tough to make it do that with modern computers. We should document our methods just like anything else. Now, passing arguments to a method. So a method that we're familiar with by now is the print line method. It does require an argument of type string. So in order to use this method successfully, we do have to pass it a string in between the parentheses. This method, parseInt, takes in a variable or it takes in a value of type string. It could be hard-coded, it could be a variable, and it returns a number of type int. So let's look at an example of a user-defined method that requires an argument, passArg.java. So here we have a program with a method called displayValue. Let's look at the definition of displayValue. It's requiring an int to be passed in as a parameter, also called an argument. Parameter and argument, by the way, are basically synonyms. You may hear me use one or the other. They're basically the same thing. And it does not return anything shown by this keyword void here. So all it does is it displays this message, the value is, and the concept here is that whatever value is passed in is stored locally in this variable called num. So we get a copy of the value being stored in this variable called num, and so when it displays here, it's going to display that value. Now it does require an int, but that could take on different forms as shown in these examples. In the first example, we have a hard-coded number. The second example, we have a variable of type int. The third example here, we have a mathematical operation which results in an int. And then this last example shows another method being called parseInt, which takes the string and returns the int, and then that int gets passed in to display value. So I think you can predict what the output will be here. So here we have the value is 5. For the first one, the value is 10 because the value of x is 10. The next one, we have 10 times 4, or 40. And finally, we have 700. Questions on that? So far, so good? Sure. Can pretty much do anything. Yeah, you can combine them with switch case statements. You can combine them with if-else statements, with loops. All those things are available. Did you have a particular idea in mind for this example?
No, not really.
Okay. But yes, for the most part, you can combine any concept we're learning with any other concept we're learning. So we're learning all these different concepts, and then to really be a good coder, you look at the problem you're presented with and think about how to apply the concepts you've learned, and more importantly, how to combine them together into something more powerful. Keep in mind that when a method is defined, it typically, if it takes an argument at all, it will be designed to take a specific type of argument. So if this display value method was defined to take an int, we cannot pass in a double. It has to be the same type. It has to match. Now we could typecast it if we wanted to make it into an int, and then we could make this work if we simply put, parentheses int close parentheses before this d to force it to become an int. Then it would work. But it does have to match the type that it's expecting. We can also have multiple arguments going into a method. So in this example, we have 2 arguments, both of type double, being passed in. And so when we call this method, we have to provide both of those arguments, and they also have to match the type that's being expected. So both of them have to be of type double in this example. All this method does is calculate the sum and then display it. It does not return the sum. It simply displays the sum. We know it doesn't return anything because of this keyword void here. But it does require two values of type double in order to function and in order to compile. All arguments in Java are passed by value. What that means is it's only the value of the variable that's getting passed to the method. There is another concept called passed by reference, in which the address of the variable gets passed. There's no straightforward way to do that in Java. In fact, Java was designed to not have that capability in order to be a little bit simpler to program. So general rule of thumb in Java, everything is passed by value. So what does that mean? Well, let's look at an example where we pass in a variable. So we have this variable number. We give it a value of 99. We display it here in main. Then we call this method called changeMe. We pass in the variable number. Over here in the method changeMe, that value gets stored in this local variable called myValue. my value is changed to 0. We display that my value. It will display 0 here. Then it will go back to main. And this variable number will be unchanged. It will still be 99. That is what is meant by passed by value. It's only the value of the variable that's getting passed, not the address or the variable itself. Okay, so even though the value gets passed in here, you can think of it as a copy. It's just the value that gets passed in. If we change the local variable that is storing that value, it has no effect on the corresponding variable back in the method from which it was called. Okay, questions on that?
When you get my value,
Mm-hmm.
that was only available to the segment of code inside those two brackets there.
That's correct. It's basically a local variable only available in this method. Yeah, if we tried to display my value up here, what do you think would happen? Yep. Okay, so that's an important demonstration about the important concept of scope. So that variable my value only exists inside of this change me method. It doesn't exist anywhere else. So if we try to use it back in main, it doesn't know what it is. Likewise, if we, well, let's see what happens if we try to display number from within change me. Let's see what that does. Okay, same thing. This doesn't know about it either because the variable number is only available in main. It's not available inside of any other method. Okay? Very good. Another question? Yeah, go ahead.
It's probably bad to do such, but if you were like using number in the second method, would it be different from itself then, or would it still be?
Yeah, you could do you could make the variable global. If you make the variable global, then it's available everywhere in the program. Then this other method would have access to the variable called number.
Right. But if you were to deploy a number in the second one, it would just be by itself in there as well.
That's a very good point. If we declared a variable called number here, you're actually ahead of me, but there's a slide, a couple slides ahead that talks about this. So that's cool. What this does is it creates an entirely separate local variable. It happens to have the same name, okay, but this number is only available inside of this method, whereas this number is only available inside the main method. And they actually have nothing to do with each other. They just happen to have the same name. So if I make this one equal to 50 and display it here, so number is 50, that's from inside of change me. Okay, the variable number inside main remains at 99. They're totally separate variables. So you can do that, but I would say it's not the best form because it can be confusing to have several variables with the same name. Yeah, we don't want to confuse ourselves anymore. General general rule to live by. I think it's good for life in general. My personal philosophy: make everything as simple as possible, but no simpler. People say that Einstein said that originally. I'm not sure who actually said it, but that's a good rule. You want to keep things as simple as possible, but no simpler. In other words, you don't want to oversimplify things and have something that's inaccurate, but making sure that your answer is accurate. Keep your code as simple as possible. Yes.
So do you have to close each method before you have a new method, or do you have a method within a method?
You do have to define methods independently of each other.
You can't have inside there another method.
No, you cannot define one method inside of another method. You can call a method from another method, but you cannot define a method inside of a method. Yes.
You have public statement void change me.
Yep.
Is the reason that's where it is and not inside the bracket because it needs to be available to the main program? If you put public statement void on within that open bracket,
Put it up here.
now go back to yeah, the bracket that's right above int number there.
This.
Right. If you put public void after that, be seen by the main program then, right?
You'd get a compilation error. But yes, it would not be seen.
The reason that's where it is because it needs to be seen.
It needs to be seen by the class, passed by value. Right? These are all, both of these are part of this class. The main method as well as the change me method are both part of this class. So they need to be seen by the class. These are great questions. Yeah.
Do you have to have, because you can make different methods, do you have to have that method, or can you just have the other one and delete that whole method? Or do you have to have one main string?
You have to have a main method somewhere. You have to have a main method somewhere. Now, what you can do, which I don't know if we'll get to it in this course, you can have a program that consists of several Java files, and only one of which has a main. Okay, you can do that, and you would import the other Java files. But somewhere in your program there has to be a main. Great questions. Anything else? I like it. All right, let's move on. We can also pass object references to a method, such as a string, but the way Java handles it is that it essentially treats it the same way as passing by value. So let's look at an example of that. We're going to pass a string into a method, and this may seem obvious, but it's important to bring up because other languages would handle this differently. So this is the way Java handles it. So in Java, we have this string called name. We gave it the name Shakespeare. We display that. Then we try to change the value by passing it into this method, which has a local variable str and changes it to Dickens. And that's changed here. Let's go ahead and run this and see if it's changed in main or not. So it's unchanged in main. So this is yet another example of the fact that Java always passes by reference. Now again, this may seem like no big deal because we saw that it passed the data type int by reference, but string is different in that string itself is an address. In other words, in C++, if we passed in a string and essentially had the same concept here where we changed the corresponding local variable to something different, the original variable back in main would get changed in C++. okay? But not in Java. In Java, it does not affect the original string that was passed in. Okay? So for us, for Java, it's still passed by value. No big deal. But if you want to learn other languages, which I recommend if you want to go into programming, you should learn as many languages as is reasonable. It's important to keep in mind that concept that this may behave differently in a different language. Any questions on that? You can provide a description of each parameter by using the @param tag. So the @param tag is another tool that we have to help us comment our code. So let's look at 2args2.java to see an example. So it still goes inside the comments, but there are tools that will take our comments and create more elaborate comments, and then we'll look for this @param tag. For our purposes, it's a good way to explain what the parameters are that your particular method requires. So let's go ahead and run this. I think we can all predict what this will do, right? We have two variables of type double. They're initialized. They get passed in to show sum, and this should calculate and display the sum. Okay, so there it is. The sum is 11.4. That looks correct based on those numbers. So the new concept here is this @param tool that we have. Yes.
So what does it actually do? What does that help you do?
Right now, it's really not doing anything, but there are tools that automatically create very in-depth, organized documentation, and they do things like look at the class and all the methods that are defined in this class and what other methods might be defined for other classes, and shows how they relate to each other. And so for that kind of in-depth documentation, such as what you see if you go to Java Docs, okay, those tools will look at this, will look for this @param tag, and will use that to help to automatically create that very in-depth documentation that looks more like a book than like comments.
So it's not actually affecting your code at all, it's just.
No, it doesn't affect the code. It affects the documentation only if you're using one of those automated tools. So let's look a bit more about local variables. We actually talked about this a minute ago because you guys are sharp and you're actually ahead of me. So local variable is declared inside a method and is not accessible outside of the method. Different methods can have, here it is, local variables with the same names because the methods can't see each other's variables. So you can do it, but it's not recommended because it makes for difficult to read code. The local variables only exist while the method is executing. When the method ends, the local variable and the values are destroyed. They're all lost. Local variables are not automatically initialized, and they must be given a value before they can be used. So let's look at this example, local vars. So here we have two methods being called. Let's look at their definitions. Texas has a local variable birds, which is 5,000. And California also has the local variable birds, which is 3,500. But they're separate, completely independent variables. Okay, if we do not give the variable an initial value, in other words, if we don't initialize the variable, we get a compilation error. Okay, I want to make sure that everyone is following all this. Would like you to turn off your computer screens